Hello and welcome to E233. I'm your instructor, Gregory Myers. This video, we're going to take another look at our realloc function, and we're going to use it to dynamically reallocate the size allotted to an array based on the number of elements that are in a file. This video is part of a larger series of videos focusing on pointers in C, and particularly our pointers demo, and assumes that you have watched the earlier videos on realloc and malloc, as well as an introduction to file I/O. So to begin with, what you want to do is go ahead and grab a copy of your realloc_02.snips file. Go ahead and copy over our function signature, function prototype, as well as the stub. Please note that we already have a display int array function in our pointers driver. And what we'd like to do is we'd like to make some very minor modifications to it to facilitate seeing our array a little bit better as it grows larger in size. And so to begin with, let's go ahead and copy that over, then close out your snips file. And what we're going to do is we're going to make some very minor changes now to our display int array. Particularly what I'm going to do is I'm going to insert a couple of additional new lines after my pointers, and I'm going to offset then the initial presentation of the values in the array by 2 spaces. So essentially all I'm going to do is I'm going to shift them in just a little bit and then make sure that each element of the array is seen on an individual line. Now, you don't have to do this, but you'll see in just a minute that our executable is going to be a little bit noisier than the ones in the past, and so it'll just make the presentation a little bit nicer. So with that being done, let's go ahead and take a look now at our realloc function. And so what we'd like to do is we'd like to leverage some of the things that we learned in our realloc_01. In the earlier version, we used input from the user to determine the initial array size and then grew it once it was larger than they had initially expected. In this example, what we want to do is we want to grow the array size as we read elements in from the file. Now, we could increase that array size every time we read in an element from the file, but that would be terribly inefficient because essentially we would be resizing the array every time we read a value in. As an alternative, we could just simply resize the array one time and make it much larger than we could ever foresee needing, but then you might have a situation where you didn't completely fill up the array. So in both scenarios, there are trade-offs. In one scenario, there's more processing involved. In the second scenario, there could be potentially wasted space. As such, we want to keep track of the actual number of elements in our array that we are using. And so just like in our first example of realloc, we want to have some temporary variables. We're going to start off with a results variable. We're going to track the maximum number of elements in the array, including the number of filled elements in the array. We want to have some sort of way to capture the value out of the file. We can consider this a chunk of the file. And we also want to have a pointer to a current integer array, as well as a pointer to a new integer array. If you recall from last time, realloc accepted 2 input arguments. The first is the pointer to an existing array that you wish to resize, and the second argument is the new size that you wish to allocate. And the return value is a pointer to a new block of memory. We need to utilize then this second variable to determine whether or not realloc was in fact successful, which leads us now to initializing some of these variables. And so we'll start off with our results, and we'll simply say that our results are equal to exit success. Our n max is going to be equal to 0. Our index filled is going to be equal to 0. The value we can also go ahead and initialize to 0, but we would also like to initialize our 2 pointers. In this case, we're going to have a current pointer that we are going to cast to int pointer, and the value is going to be null. Now, truthfully, that casting is unnecessary, but it just gets us into the habit of remembering that it is a pointer to an integer array or a block of memory that stores integers. We want to do the same thing with our new variable, which then leads us to needing a way to read the data out of the file. And that means that we need one more variable, and that is going to be a file pointer. In this case, we're going to call it input. And what we want to do now is we want to return the results. Now, the first step is let's go ahead and open the file or attempt to open the file. So we say input is equal to fopen, and we'll just go ahead and hard code our file name, our input_01.txt, and we want to open it for reading. And as always, whenever you open a file, we want to check to make sure that the file pointer is not equal to null. If it is equal to null, we have a problem. So if it's not equal to null, we want to do something. And under the else branch, we want to notify the user that something went wrong. In this case, error failed to open input_01.txt, followed by a new line. And at this point, we simply want to set our results equal to exit failure. Now, under the do something part, well, what we want to do is we want to pick out each of the integer values in this file. Now, I'm intentionally not scrolling to the bottom because I want to leave some sort of mystery as to how many elements are in this file. You might already recognize this file from an earlier video, but what we want to do is we want to assume that we have no way of knowing how many elements are in this file. And so what we want to do under our do something branch is we simply want to continue to read while our fscanf, utilizing our input file pointer, we're going to attempt to read an integer, and we are going to store that at the address of the value variable. And while that is not equal to end of file, we want to store the value in the array. Well, this is where it gets a little bit interesting, because remember that we have our current array pointer points to an array of integers, but we assigned it the value of null. That's another way of saying that our array can't store any values yet until we grow it to the appropriate size. And so what we're going to do here, since we don't know how many elements are in our file, we're going to pick some initial value for our current array and subsequently our new array. And so what I'm going to suggest for this particular example is that we grow the array in blocks of 10. In other words, 10 integers at a time. If we wind up, for instance, with 95 integers, we would have 5 empty spaces left over, but that's okay. That's a decent sacrifice. If I grew it in a smaller amount, I would simply end up reallocating the array too many times. So for instance, if I only allocated it in chunks of 2, then I might end up unnecessarily reallocating the array too many times. So we'll start with 10. And to do that, I'm simply going to have an if statement that checks to see whether or not the current array is in fact filled. And so the way that I do this, I'm going to check to see if my index filled is less than our n max. And if it is less than our n max, we simply insert the value into the array. Under the else, we need to grow the array and then insert it. So we'll focus on this first part of the true branch because we've seen this one before. This one's pretty straightforward. This is just going to say current square brackets index field is going to be equal to whatever that particular value is, and then we simply increment our index field. Not a big deal. It gets interesting though when we first have to grow the array. And to grow the array, we're going to leverage a similar trick to what we saw in our realloc_01, and that we are going to use that new variable, and we're going to use the realloc function, and we're going to take as the first input argument the current pointer. In other words, the current array or the pointer to the current array. And then what we're going to do is we're going to specify that we want to grow it to a certain size. And in this case, what we want to do is we want to increase our size by n max plus 10. In other words, however many elements are currently in the array, we simply want to add 10 to it. And we choose then the size of the data type of the array. In this case, it's going to be the size of an integer. So, for instance, the first pass where our current and our new arrays are both null, we would say that we would use our n max, which was equal to 0 plus 10, or a total of 10, times the size of an integer, which is 4, meaning that we would allocate 40 bytes of memory for this array. As always with realloc and with malloc, we want to check to make sure that the new is not equal to null. If it is not equal to null, we continue. Else, we need to let the user know that there was a problem. In this case, printf error failed to allocate enough memory, followed by a new line. And we also want to set our results equal to exit failure. Now, under the continue, what we want to do is just like in our realloc_01, we want to assign whatever that address was that we got from realloc and assign to our new variable, we want to now assign to the current variable. Now, note also that after you make a call to realloc, you want to make sure to cast it to the correct data type. So in this case, remember that our new and current pointers point to integer arrays. So it's important that we remember to go ahead and cast this to an integer pointer. At this point, we can simply say current square brackets index filled is equal to value, much like what we did in the if branch of our if-else statement. And we can also increment our index filled, but we also want to keep track of the changes that we made to the total array size. And in this case, what we're going to do is we're going to say n max is equal to n max plus 10. Now, what I'd like to do is I'd like to keep track of our growing array, and I'm going to utilize our display function. We probably don't need to display the array every time we update an individual element, just when we grow the array. And so what I'd like to do here is I'd like to include then a display int array, and I want to pass to it our current integer pointer, as well as our n max after we have updated it. So the idea here is after the first iteration of the while loop, when we pull out our 9, we should have grown the array from null to 10 elements, and we should have inserted the value at the 0th location, or that first location in our newly assigned block of memory. At this point, we can go ahead and build it. We have no errors, so we should probably go update our main to include this particular switch. I'm just going to go ahead and copy our realloc _01 and change it to 2. And we also need to update our help. In this case, once again, I'm simply going to copy and paste from realloc _01. And at this point, what you need to do is you need to make sure that you have a copy of your file in the directory where your executable is. So in this case, you'll see that I have my input _01.txt resides in my pointers demo.exe folder. If it did not exist there, so in other words, I'm going to take just a second to delete it or rename it. How about we'll just do that. And in this case, if I try to run my pointers demo without a switch, I get a call to my help. It does seem as if I did not rebuild it. Let me rebuild it one more time. There we go. There is my help. If I run it with my realloc _02 switch, you'll see that I get a warning that says it failed to open the input _01.txt file. And that is just simply because it does not exist by the correct name. Yes, I want to change it. And you'll see now that I am reading the file, and we'll start up here. You'll see that first I have allocated 10 chunks of memory, starting with this 0CF0. Notice how that's in a block of memory. And I have assigned them the value of 9, but the additional 9 values are still garbage or unpredictable or useless, however you want to think about it. And then I make another call to my display function only after I have essentially ran out of memory. So I'm going to take a second to realign this for just a second here. Take this here, bring this over here so we can sort of see what's going on. And so initially, when my array was 0 length, in other words, I didn't have enough room, I used realloc to allocate enough room for 10 pieces of memory. And then in subsequent iterations of the while loop, I filled up those 10 pieces of memory. And when I ran out of memory or enough memory in my current array, then I simply allocated another block of memory. So notice here it's 0CF0, but then what I get here is additional spaces in memory. So for a total of 20 locations in my array. And then I start filling those up. Once again, once I fill up those, I grow it to 30. You'll see there are my 30 locations in memory. I grow it to 40, I grow it to 50, I grow it to 60, 70, 80, 90, and then finally 100. Now we can do one additional thing here. You'll notice that I have all but those last 9 pieces of memory filled with actual values. The rest of it is just simply junk. What I can do here is I can follow this up with one last display. In this case, what I'd like to do is I'd like to display it after my while loop. And I'd also like to take just a second to remember to close the file. So in this case, I want to close my input file after my while loop. And so I'll go ahead and build it one more time. And you'll see that now I have the complete file, and we can verify this because we can look all the way down here at the bottom. The last three values are supposed to be 5, 1, and 4. There are my 5, 1, and 4, and you see the memory locations in memory, not in the file, but rather in that current array. And you can play around with this by adding additional values here. So for instance, let's make sure that we have the correct file open. I'm just going to drop another value in the file here. I'm going to put in something completely different, 99, just that stands out. I'm going to rerun this, and you'll see that 99 is populated, but since the array is now a total of 110 elements, there is the last 9 elements that still have garbage in them. So we'd actually want to consider passing to the display int array, not our n max, but what we could display is our index filled. And at this point, then, we would only see the values that were truly used as opposed to the values that were allocated. In this case, you'll see I stop at that very last value. So hopefully you understand sort of the difference now between the two. The memory's still allocated. There's 110 elements that are still allocated, but in this particular case, only 101 are used, with the other 9 being allocated, but essentially unused. I'm going to put a little comment here, and this is going to be versus our n max. So hopefully you found this video useful. As always, if you've got any questions or comments, don't hesitate to ask, and thank you for watching.